What's up, everybody? We're going to be going over the Algebra 2 Unit 6 test review. This is our last unit test, alright? We're almost there, okay? This is kind of a hard test, so really make sure you dive in and you get focused, okay? So the first problem we're over is just problem number 1, which says describe the transformations of f of x equals -5 times the cube root of x minus 9, okay? And all it wants us to do is to write out the transformation, so this should be pretty easy for us, okay? This minus sign right here, that just means I'm reflecting across the x-axis, okay? Then, this 5 right here, well, that's multiplying to the function, the cube root function, to the parent function, okay? So that's a vertical stretch by 5. Okay? And then this minus 9 is outside the function, so it's actually going to be dropping our function down, so we're going down 9. Alright? And that's all there is to that one. That's all there is. Okay? So now, let's go on number 2. It says solve the cube root of 3x minus 1 minus 2, which equals 0. Alright? So the first thing, this problem, what we want to do is we want to get the cube root by itself so that I can eliminate the cube root. So in other words, what I need to get rid of first is this minus 2. So I'm going to add 2 to both sides. Alright? So then that gives me the cube root of 3x minus 1 equals 2. Now, you should know that cube rooting is the same thing as raising something to the 1/3 power. So I'm going to go ahead and draw that out. It's not a required step that you write that out, but I want you to see get a chance to see it. Alright. So, nothing changed from this step to this step. So how do I get rid of a cube root? How do I get rid of a power of 1/3? That's right. I raise it to its reciprocal power, which would be 3 over 1, which is really just 3. You don't have to write 3 over 1. Okay, I'm just trying to show you what's happening. Alright. So, powers raised to powers multiply. So 1/3 times 3 over 1 is just 1. So I can just write this as 3x minus 1 equals 2 raised to the third is 8. So now I want to finish solving. So I'm going to add 1 over. So I get 3x equals 9. Then divide both sides by 3. And I get x equals 3. Alright? Hopefully you're like, oh, okay, that's making sense. It's making sense. I'm starting to feel confident. Alright? I'm starting to feel a little confident about this test. Okay? Now, let's look at problem number 3, where it says, it takes 6 students 8 hours to mow the field Saginaw High School. The number of hours varies inversely with the number of students. How long will it take 4 students to mow the fields? Well, hopefully you're like, Michelle, and I remember this. Inverse variation is just y equals k over x. And I remember that I have to find k, the constant of variation, first. So we know that hours varies inversely with students. So y varies inversely with x, so I say 8 hours equals k over 6. Multiply both sides by 6, and I get that the constant of variation is 48. So then I can use that information to find how long it will take 4 students to mow the fields. So now I plug my k in. I know that y is my time. So I can say y equals 48 over x. But this time, rather than having x there, I'm going to replace that with a 4. So I'm going to get 48 over 4, which is just 12. Oh, my equal sign didn't. I don't know why my equal sign happens sometimes and doesn't happen other time. So we get that it only take them 12 hours. Alright, let's move on to our next problem. Problem number 4, which says solve 2x over x minus 5 minus x over x minus 3 equals 6 over x squared minus 8x plus 15. So first off, I have a bunch of rational functions here, and we're solving rational functions. That means I want to get a common denominator so that I can eliminate all my denominators. Okay? So struggling with factoring, I do have a video over factoring, so you might want to go back and watch it, okay? In fact, if I can, I'll figure out and I'll get the link. I think it's going to be here. I'm not entirely sure. It might actually be over here. I'm going to try to be fancy for you. All right? So hopefully right now you're like, okay, so outside of Mr. Dillon's weird attempt at fanciness, this side clearly needs an x minus 3 in its denominator. And this side, this fraction clearly needs an x minus 5. Alright, so then that's going to allow me to cancel out all my denominators. Then I multiply x times 2x, that's 2x squared. Negative 3 times 2x is negative 6x. X times x and the minus sign becomes minus x squared. X times negative 5 with the minus sign becomes plus 5x, because it's kind of like a negative x. Negative x times negative 5 makes positive 5x equals 6. So now the next step we want to do is we want to combine like terms. So 2x squared minus x squared, that's just x squared. Negative 6x plus 5x, that's negative x, equals 6. Okay? So now with that, what we want to do is realize we have a quadratic situation. So we need to make this guy equal 0. So we're going to write x squared minus x minus 6 equals 0. Now we're going to factor this guy and set each factor equal to 0. So now what we need to do is factor x squared minus x minus 6. So that factors to being x minus 3 times x plus 2. Alright, and now what we're going to do is we're going to set each, that's a 0 right there, I know it's hard to tell, is we're going to set each one of these factors equal to 0. I'm going to do this up here because I'm running out of space. So I get x minus 3 equals 0. And then I get x plus 2 equals 0. And I get then that x equals 3 and that x equals negative 2. So both of these would be my answers, except for the fact, look at this denominator of x minus 3. Okay? This denominator of x minus 3 means that if x was 3, 3 minus 3 would be 0, which I can't have. I can't divide by 0. So that is not helpful. This is my only answer. Alright, moving on to problem number 5 here. A gardener can weed his flower bed in X hours. It takes his partner 2 hours less to weed the same flower bed. Together they can weed the flower bed in 4 hours. Model the situation. So this is a work rate problem. Okay? So work rate means I do 1 over each one of the times equals 1 over the combined time. So then 1 over x for the first guy, plus his partner can do it in 2 hours less. So that would be 1 over x minus 2 equals 1 over the combined time would be 1 over 4. And we're done, because it just wanted us to model the situation. Alright, so let's move on now to problem number 6. It says, write the domain of the function. Okay, remember, domain is all possible x values. It's going to the left forever, so that's negative infinity. 2, where does this guy stop? It stops right here at an x value of 5, because there's a vertical asymptote there. Unioned with, where does it pick up again? Right here at 5. 2, it keeps going forever, so that would be infinity. And that would be the domain. Okay, let's move on to problem number 7, which says, which of the following shows the maximum minimum values of the function, maximum y values, I shouldn't say which of the following, it's asking us to find the maximum min y values of the function 1 over x on the interval 2 to 5. Remember, this interval are x values, okay? These are x values. So if you want to, you don't have to, but what you can do is you can make a table, and you can say 2, 3, 4, 5, and all the values in between. It doesn't say just whole numbers. So technically we have 2.5, 3 and 1/3, okay? But we're just not going to write those out. And then you're going to plug them in back to this original parent function. So we'd get 1 over 2, 1 over 3, 1 over 4, and then 1 over 5. And simply is asking which one's going to be the maximum y value and which one's going to be the minimum y value. But remember, with fractions, it's opposite of what we think a lot of time. 1/5 would be my minimum, and 1/2 would be my maximum. Okay, moving on. Let's go to problem number 8. It says add, simplify completely. Well, in order to add fractions, we need a common denominator. In order to get a common denominator, I need to make sure everything is as factored as possible so I can see the different factors of the different denominators. So this guy has a factor of just x minus 1. However, this guy's over here, it can be factored by greatest common factor. X squared and x both have an x in common. So that becomes x minus 1. So now hopefully you're aware of like, oh, okay, so this guy needs something in its denominator to get it common. It needs another x. So we'll multiply. Now our denominator is going to be the same, so I can make this one big fraction over a single denominator. So x times x, that's x squared, so I get x squared plus 4x, that's coming from this guy right here, minus 5, over x times x minus 1. Now, some people might say, oh, we're done. Well, it didn't say just add. What did it say? Simplify completely. So that means I also need to try to factor and cancel stuff out. Okay? So the factors of this guy right here, you can tic-tac-toe it, and you would get x plus 5 times x minus 1 all over x times x minus 1. Okay, well, what can I do from there? That's right. I can cancel out the x minus 1s, and I'm left with x plus 5 over x. And that is as factored as you can do. All right? All right, so let's move on to problem number 9. It says, what is the graph of y equals x minus 1 cubed plus 2? Well, what is this minus 1 going to be doing? Moving us to the right one. What is this plus 2 going to be doing? Moving us up 2. So it can't be A because that went down. Can't be B because that went down. Could be C, except we didn't go to the right. We did go up, but we didn't go to the right. So then it's got to be D. Okay. Moving on to problem number 10 now. Problem number 10. The graph represents the function. It gives me the function right there. And it even graphs it for me. But it says, what is the range of the inverse? It does not want the range of this guy. It wants the range of this guy's inverse. Well, what do we know about inverses? All you do is switch x and y. So what is y if I was of the inverse? Well, it's the domain, the x of the original. So I'm just looking at the domain of the original to get the range of the inverse. So what is the domain of this guy? It's all possible numbers. So that would be the range of this guy. So it would just be B. On to problem number 11, it says solve. Okay. So if I want to solve this, notice the base, the parentheses, I say base because it has an exponent power, is already by itself. Nothing is happening to the parentheses. So that means what I can do first is get rid of the power of 1/3 by raising it to its reciprocal. Okay? Because then powers raised to powers multiply. And when you multiply reciprocals, they cancel each other out. They become 1, which is kind of like canceling out. Okay? So that gives me 3x minus 4 equals 8. So then I'm going to add 4. So that gives me 3x equals 12. Then I'm going to divide both sides by 3. So that gives me x equals 4. So my answer is x equals 4. That's a really bad 4, but that's what it says. Number 12 says divide and simplify. Well, how do we divide fractions? Like, what's one of the first things your brain should think? Hopefully you're like, keep, change, flip. That's right. We keep the first guy. We change the multiplication. And we flip the second guy. Now what we want to do is we want to factor and cancel. For the sake of space, I'm just going to factor this. I'm going to erase it, but I'm just factoring it. Same thing with this guy right here. I'm erasing it just because I'm just going to factor it. So x squared minus 16, you can tic-tac-toe that and get x plus 4 times x minus 4. This guy you can factor to being x minus 4 times x minus 4. Alright, then the x minus 4s are allowed to cancel. The 4 and the 20 are allowed to cancel, and that becomes 5. So we're left with just 5x times x minus 4 over x plus 4. Okay, and there we go. Alright, moving on then to problem number 13. It says, what is the inverse for this function? Well, how do I find an inverse? What is step 1 to finding an inverse? That's right. switching x and y. So we switch x and y, so this becomes, oh, I wrote y and I meant to change that to x, equals 1/2 times y minus 4 raised to the third. So now what I want to do is I want to solve for y. So I got to get rid of the 1/2 so I can divide both sides by half. Well, you should know that dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So the reciprocal of 1/2 is just 2. So I get 2x equals y minus 4 cubed. Okay? So now I want to get rid of the power of 3. So I'm going to raise both sides to its reciprocal, because that's how we get rid of a power we don't want. To undo a power, we raise it to its reciprocal. Because powers raised to powers multiply, so those cancel. So I have 2x raised to the 1/3 equals y minus 4. So now what I want to do is I want to bring the negative 4 over. So I get 2x raised to the 1/3 equal plus 4. I brought the 4 over, equals y. And I'm done. Now, I would accept that as a final answer, but I want to point out a couple things. 1/3 can also be written as the cube root. So you could write the cube root of 2x plus 4. And then instead of writing y, you could write the notation for inverse, which is f raised to the negative 1 of x. So you could also write it like that. Okay, so let's move on to problem number 14. A function has asymptote at x equals 7, y equals 9. Which of the following equations could represent this function? So if you look at A, B, C, and D, which C and D are up here on the other part of the page, you can't see them, is that these are all types of rational functions, which is 1 over x. Well, how would I move a vertical asymptote, which is usually at x equals 0, how would I move that to x equals 7? Well, that's moving it to the right 7. How would I move it to the right 7? Well, I would say minus 7. And then I usually have a horizontal asymptote at y equals 0, but now it's at y equals 9. So how did I move it there? By adding 9. Now, when you look at A, B, and C, D, you'll notice they all have a 3 on top. So it doesn't matter. I don't care where that 3 came from. If they all have it, I can ignore it. So the only answer I care about must be A, because that's minus 7 plus 9. All right, problem 15. Which equation has the graph below? Well, this is clearly a rational function. I've clearly gone from, rather than having a vertical asymptote at x equals 0, now it's at x equals 1. And rather than having a horizontal asymptote at y equals 0, I now have one at y equals 3. So which one of these fits that mold? Well, x minus 1 means right 1, so I know it can't be A or C. So then what's the difference between B and D? Because they both have the plus 3 for the y. Well, look at that 5. Look at that 3. Where is that coming from? We'll go back to the graph and I'll tell you how. Those are coming from when you are at the intersection of your two asymptotes. If you were to count up and then over to a point, as long as you're only going 1 unit over, that is your A value. That's the value that's on top of the fraction. So I went up 1, 2, 3 over 1. That's perfect. So that means it would be 3. So then my answer has got to be the selection number C, letter C. Nope, not C. Sorry. D. Because that's the only one that went up 3. Okay? Alright guys, sorry at times that video kind of got weird. I do apologize for that, but that's the last question. This is a hard test. Make sure you take some serious time to study. Alright guys, thanks for watching. Please send me any questions you have. Let me know if there's something I've done wrong. Alright guys, have a wonderful evening.